Hello everyone, this is Learning Target 14, Radical Functions in Algebra 2, and Lesson 25-1, Square Root Functions. Let's take a look at our learning target. Describe transformations of the square root functions y equals to square root of x. Language objective. Use academic vocabulary like translation, reflection, vertical stretch, or shrink to describe transformation. School-wide learning outcomes. Critical thinkers, effective communicators, lifelong learners, and conscientious members of society. Let's see what you already know. Describe the transformation of g of x as compared to the graph of f of x. This is for quadratic function. So the graph of g is translated 2 units up as compared to the graph of f. Second, describe the transformation of g of x equals to the difference of x and 1 squared as compared to the graph of f of x equals x squared. So the graph of g is translated 1 unit to the right as compared to the graph of f. And then the third one, the transformation of g of x equals to the difference of x and 1 squared plus 2 as compared to the graph of f of x. So the graph of g is translated 2 units up to the right as compared 2 units up and 1 unit to the right as compared to the graph of f. Now let's go to our lesson. Graph and describe transformation. So I'm going to start with the parent function f of x equals to the square root of x. So these are the set values of x that I will use for the graph of this parent function. So if I plug in 0, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Plug in 4, the square root of 4 is 2. And plug in 9, the square root of 9 is 3. Okay, then we're going to plot this point to get a graph. First point, we have 0, 0, 1, 1, 4, 2, and then we have 9, 3. And if we're going to connect this, we will have the graph of our function. So that is our parent function, f of x equals to the square root of x. Okay, so I'm going to go back to the table of values because I want to describe the transformation of the g of x compared to this. What we have here is the graph of the parent function. So now I will use the same value of x and plug it in here. So 0, square root of 0 is 0 plus 1. So I'll get a value of 1. Square root of 1 for the second plus 1, that will be 2. Then the square root of 4 is 2 plus 1, it is 3. And then the square root of 9 is 3 plus 1, that will be 4. And these are the y values, or these are the g of x values with this set of x's that I will be plotting for the next part. Okay. We have again here is the graph of our parent function. So we'll plot the points from the table of values earlier. We have 0, 1. Then we have 1, 2, 4, 3, and then 9, 4. And connecting this, we will get the graph of the square root of x plus 1. So as you could see right here from the parent functions, what happened? The graph has translated at what unit? So the graph of g of x is translated 1 unit up. Second function that I want us to see the graph is g of x equals to the square root of x minus 1. But here, if I will use the same axis as the parent functions as I have completed this graph, so 0 will give me imaginary number. With 1, I will be okay. 1 minus 1, 0. 4, yes. But the thing that I don't like using 4 is I will have no exact value. The same thing with 9. Okay. Since we already know, or we had seen a graph, we have here the graph of the parent functions. I will change this axis into values that I will have an exact square root. Okay. I cannot have 0 because that will be imaginary. That is part of our domain. I cannot have 0 for the x for this kind of function. So let me change that table of values as 1. Then I will have 2, and then this would be 5, and then this will be 10. So I plug it in here. What's 1 minus 1? 0, and the square root of 0 is 0. And then here 2 minus 1 is 2, and no, 2 minus 1 is 1, and then square root of 1 is 1. And then 5 minus 1 for my next value, that would be 4, and the square root of 4 is 2. And then here 10 minus 1 is 9, and the square root of 9 is 3. So to plot or to graph this, I will be using this coordinates, and this would be my y coordinates. Starting again with our parent functions, I will plot those x and y coordinates from the previous table of values. We got 1 and 0, 2 and 1, 5 and 2, and then 10 and 3. And connecting these points, we'll see the graph of our second function, g of x, which is the difference of x and 1 inside the square root. Okay, so as you could see, what happened from this curve, this square root of x graph, to get the second function, it is translated 1 unit to the right. Okay, so translated 1 unit to the right. So now for the next part, I will just be using the Desmo, so it will be easier for us to do the comparison. Here again, our square root of x parent functions, and then the second one, this is square root of x plus 1 minus 3. If you will compare it to what happened when we have the square root of x minus 1, this one is the square root of x plus 1. So what happened? There is a translation of this graph to the left of 1 unit, and then down 3, or yes, down 3 units. So let me show you the function for that. So hold on. The first one is my square root of x, and then the second one is my square root of x plus 1 raised to 0.5, which is the same as using the square root of x. Okay, so the point that I have in the parent function, which are 0, 0, 1, 1, 4, 2, those are the only visible points that I have here. They have been translated first to the left of 1 unit. So let's check on that. So 1 unit here, and then translated 3 units down, 1, 2, 3. So here 1 unit, 1, and then 1, 2, 3. My other point right here, this is 4, 2. So 1, and then 1, 2, 3. Okay, so we have this, the square root of x plus 1 raised to 0.5, which means I'm taking the square root. Okay, all right, let me get to a second part. Okay, so I changed the notation so it will be similar to what I used before. So now here my comparison will be still the parent function, and this one, which is y is equal to 2 square root of x. So let me activate the graph on that, and look what will happen. So here from 0, 0, it is the same thing. The graph, the second one, also start at 0, 0. But what about the 1, 1? The 1, 1 changed to 1, 2. Then my 4, 2, I don't have it visible. Let me see if I can fix that. There you go. So my 4, 2 is now 4, 4. So what do you think is happening with this 2 square root of x? So yes, the y values were multiplied by 2 with this 2 square root of x. And that is what we call the vertical stretch. Okay? So this number, anything, the absolute value of this one, anything from greater than 1, that's after that you have taken the absolute value, will cause a vertical stretch. Okay, now So still our parent function is here, but this time I'm going to use this 0.5 square root of x means 1/2 square root of x, and take a look at what will happen. So my 0, 0 is still 0, 0. Now 1, 1 from the parent is no longer 1, 1. Can you read what's this? This is 1 and 0.5. Our 4, 2 is now 4, 1. So what's happening if you have this 0.5 square root of x? Yes, the y values have been multiplied by 0.5, or you had taken the half of all the y values of the parent function. So that's this kind of thing. Then the last one is this negative square root of x. So we have the visible graph of the parent functions. I just need to adjust this so we can really see what will happen to this graph as compared to the parent function. Okay, there you go. So what do you see? It's like your parabola open sideways, huh? So when it's only square root of x, that is represented by this green, red curve. This is our parent function. Now, the black part of it, this negative square root of x causes, this is the reflection over the x-axis. Okay? So those are the kind of transformations I want you to be able to use in describing the transformation, and I will be adding more notes on that.